What's going on, everybody? Welcome back to the channel. We have this interesting question that says find the value of x given that 9 to the power of x minus 4 to the power of x is equal to 6 to the power of x. Well, our first step will be for us to divide through, which is divide each term by 4 to the power of x. So I have 9 to the power of x. So I'll divide by 4 to the power of x minus, I have 4 to the power of x. I'll divide by 4 to the power of x equal to, I have 6 to the power of x. I'll divide by 4 to the power of x. Now our next step will be for us to apply the law of indices that says when I have a to the power of n divided by b to the power of n, this can be written as a over b all raised to the common power of n. So I'm going to be applying that here. So we have this becomes 9 over 4 all raised to the common power of x minus this 4 to the power of x divided by 4 to the power of x is 1. So I'm going to be putting 1 here equal to, now apply the law here. This becomes 6 over 4 all raised to the common power of x. Good. Now notice that 9 is a perfect squared, which means it can be written as 3 squared all over. 4 is also a perfect squared, which means it can be written as 2 squared. And this is raised to the power of x minus 1. This is equal to, now 2 can divide. 6 divided by 2 is 3 all over. 4 divided by 2 is 2. And this is raised to the power of x. Very good. Now we can apply the power law of indices here, just as what we have here. So this can be written as 3 over 2 raised to the common power of 2. And remember, this is raised to power x. So I'm going to be raising all this to power x minus 1 equal to 3 over 2 all raised to the power of x. Now we can switch the positions of these powers because they actually multiply according to the law of indices. That means this expression can be written as 3 over 2 all raised to the power of, now switch the position of the x inside. Now we're going to be taking the 2 outside. Very good. Minus 1 equal to 3 over 2 all raised to the power of x. Good. Now we can introduce substitution by saying that let 3 over 2 all raised to power x be equal to y. Well, looking at this, you see that 3 over 2 all raised to power x will always be positive. So that means the value of y will always be positive. Let's take note of that. Now rewriting, we have y squared minus 1 to be equal to y. Let's push y to the left-hand side. So we have y squared. As y crosses to the left, it becomes minus y. Here we have minus 1 equal to 0. Now we're going to be using the quadratic formula to solve this. Our a here is 1, our b is negative 1, and our c is also negative 1. Now using the quadratic formula, y equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Very good. Now we're going to be substituting here. So the value of y now becomes minus b. b is negative 1 plus or minus the square root of b squared. So that will be negative 1 squared minus 4 times a times c all over 2 times a. That is 2 times 1. Very good. Now continue. We have y to be equal to negative times negative gives positive. So I'm going to be having positive 1 plus or minus the square root of negative 1 squared is 1. Now this negative times this negative is positive. So 4 times 1 is 4. all over 2 times 1, that will be 2. Then simplifying, we get y to be 1 plus or minus the square root of 1 plus 4 is 5 all over 2. Good. So the two values of y we have from here are, we have 1 plus the square root of 5 over 2, and we have y to be 1, this time minus the square root of 5 over 2. Well, like we said, y is always positive. And looking at the first y, we can see that this is positive. So this is accepted. And looking at our second y, you notice that it is negative. So we're going to be rejecting this. So we're going to be working with this. Now recall from our substitution that we said let 3 over 2 all raised to power x be equal to y. Now we substitute the value of y here. So we have 3 over 2 all raised to the power of x to be equal to y. Y is 1 plus the square root of 5 all over 2. And now an expression like this will take the log of both sides. So I'll take the log of 3 over 2 all raised to power x to be equal to, I'll take the log of 1 plus the square root of 5 over 2. Good. Now we're going to be applying the law of logarithm here that says that when I have the log of a raised to a power of p, this can be expressed as p times log a. And let's apply this here. So this expression now becomes x, which is the power, times log 3 over 2. Very good. And this is equal to log of 1 plus the square root of 5 all over 2. And now since we're looking for the value of x, we have to divide both sides by log 3 over 2. So I'll divide the left by log 3 over 2, and I'll divide the right by log 3 over 2. And I'll notice that log 3 over 2 cancels out from the left, leaving behind x to be equal to the log of 1 plus the square root of 5 all over 2, all over, now the denominator, the log of 3 all over 2. Good. But we're not going to be stopping here, so we're going to be breaking this down. Now we've got to a stage where we're going to be applying the law of logarithm that says when I have the log of a all over b, this can be expressed as log a minus log b. So we apply this on the numerator and on the denominator. So we have x to be equal to the log of, now this will be 1 plus the square root of 5 minus log 2. Very good. All over. Now we apply that to the denominator as well. That means the denominator can be expressed as the log of 3 minus the log of 2. Very good. Now I don't want to stop here. We're going to be writing the approximate value of what we've just got. So this becomes x equal to log of 1 plus the square root of 5 is 0.51 approximately, minus the log of 2 is approximately 0.3010, all over the log of 3 is 0.4771 approximately, minus log of 2, which is this, is 0.3010. And when you compute this, we're going to be having an approximate value of, okay, that will be 1.87. An approximate value of 1.87 will be our correct answer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.